This is lesson 5. We are going to be talking about parallel lines and transformations. So we're going to start off with a parallel line lab. We're going to read each step carefully. We are going to answer the questions about these parallel lines AB and CD graph below. So step 1, let's measure the distance between the lines AB and CD. So taking my ruler, I notice I'm going to be measuring in centimeters. So if I measure the distance between, I can see that that is about 2 centimeters. Now, step 2 says find the slope of the lines. Remember, slope is rise over run. So between A and B, I'm going to rise 2. I'm going to run 3. So my slope would be, for this first line, 2 over 3. Now, for line CD, this time I'm going to rise 4. And I'm going to run 1, 2, 3, 4, 5, 6. So 4 over 6, now that reduces to 2/3. Now notice that these slopes are the same. Before we move on, I just want to come up with the equations for these two lines. So AB, we know the slope already. The y-intercept is 2, so the equation for this line would be y equals 2/3 x plus 2. And for CD, we have y equals 2/3 x because the slope is the same. This time it crosses the y-axis at -1. So there are the two equations. Now, step 3 says, let's trace both lines with a marker on the overhead. So that's the transparency. So I'm going to place that transparency over the graph, and I'm just going to trace the two lines that I have on the transparency. I'm also going to take a different color here. Let me grab one. Just so that I have these are the axes right here. Okay, so now what we're going to do is we're going to use the traced lines, what we just did, to investigate each transformation. So the transformation at the bottom, let me move this up for you. It says reflect over the y-axis. So this is my y-axis. A reflection is a flip, so I'm going to simply flip my transparency, and that would be considered a reflection. You can still see the blue lines. It says find the distance between lines A and B. So again, we are going to find the distance between the two blue lines, which is still 2 centimeters. It says, let's find the slope of AB. So I'm talking about the slope of this blue line, the new line AB. So if I take 2 points on this line, so maybe like this one right here that goes through B, and how about this one right here? Now, the slope is your rise over run, so we're actually going down 2, so -2, and I'm running 3. So that's the slope on my first line. Now, the second line, okay, is going to be this line down here. So I am going to pick 2 points on that. You know what? I should have actually, now that I'm thinking about this, I'm going to go back real quick. Those are the 2 points that were picked. I should probably have labeled C and D as well. Okay, now when I flip them, I will know what to find the slope of. Okay, so now CD. This time I'm going down 4 and I'm running 6. So down 4 over 6. Now this does reduce to -2/3. All right, so that's our reflection. I'm going to go back to the original. This time it says to do a translation, right 3, down 2. So I'm going to move this whole thing. I'm going to go right 3. So 1, 2, 3. And I'm going to go down 2. 1, 2. So here's where I'm at. Now, again, if I were to measure the distance in centimeters between those two lines, those lines did not move, so it's still 2 centimeters. Now I'm going to find the slope of these two lines. So from here to here, I'm still going up 2. I'm running 3 between points A and B. For C and D, I'm going up 4. I'm running 6. That does reduce to 2 over 3. All right, last one. Let's go back to the original. And we are going to find the distance, or after, let's first rotate 180 degrees. That's a full, that's 90. and 180. So here's a 180 degree turn. Okay, so the distance again, the lines did not move, so it's still 2 centimeters. This time between A and B, okay, I'm going to go up 2 over 3. For this one, I'm going up 4 over 6. 4 over 6 reduces to 2/3. So now that I've done all 3 of those different transformations, let's answer some questions about that. Actually, if we go to the next page, it says, let's make some conclusions about translating parallel lines. So translating is when we just moved the lines over 3 down 2. And did you notice that the distance still stayed the same and the 2 lines were still parallel? Okay. They still had the same slope. They just had different y-intercepts. So I'm going to write the distance between the lines is the same. That never changed. And the 2 lines remained parallel. Now, I just want to remind you that parallel lines, they always have the same slope and different y-intercepts. Remember, we learned that a couple modules ago. And if you were to look at the equation that we came up with, you're going to notice that they had same slopes, different y-intercepts. All right, so let's go into example 2. This time we have 2 parallel lines again. We're going to draw the images of these parallel lines after a clockwise rotation, okay, 90 degrees about the origin. So here's our graph. Now, when we talked about rotations, we did it 2 different ways. One way we did it was with the rule, and I'm going to remind you that rule is that you take any point and you flip X and Y and you negate the X. That's the rule. So you could use that, or you can actually rotate your paper 90 degrees clockwise. So, you know, I like to do it the rotation wise. So I'm going to go clockwise, 90 degrees, I'm going to stop. So I'm going to list my new points here. So E prime, if I was looking at this without numbers here, this would be, I wouldn't go left or right at all. So that would be 0. And I would go up 6, which is positive 6. F, okay, I'd be going over right 3, which is positive 3, up 3, which is positive 3. I'm just going to mark down G prime, the new G. I would be going left 2, but not going up. And H would be to the right 2 and down 4. Okay, so there are my 4 points. I'm going to go back to graphing this like normal, and I'm just going to graph these 4 points on the grid. So 0, 6 is right here. This would be my E prime. 3, 3 is my F prime. Okay, G prime is -2, 0. And 2, -4 would be my H prime. So I'm going to take my ruler and just make those 2 lines. Okay, I'm going to just draw my arrows. Okay, I'm going to do the same thing with this one. Okay, so there are my 2 new points. Now, before I move on from that, I should probably list all my old points. So E originally was -6, 0. Now my new E prime is 0, 6. My original point F was -3, 3. My new point F is 3, 3. G originally was -0, -2. My new G is -2, 0. And my H originally was 4, 2. And H prime is now 2, -4. So it says, after the rotation of 90 degrees clockwise around the origin, let's name 2 characteristics about the parallel lines that are preserved. Remember, preserved just means stays the same. So what are they? They are still parallel. So they are still parallel. And if you notice, they're still going to be the same distance apart. So they are still the same distance apart. Now we could take this one step further and kind of examine their equations of their lines. So let's just take a look at what these equations look like. If we're going to talk about the original line, EF, okay, the slope of that line is, let's see, E to F. We're going up 1, 2, 3 over 1, 2, 3. So 3 over 3 is 1. So X plus, oh, not X plus, X equals, try that again, Y equals X. And then the y-intercept is at 6, so X plus 6. And the original line GH, okay, that slope is going to be up 1, 2, 3, 4 over 1, 2, 3, 4. So Y equals X minus 2. So if you just notice, these lines we know are parallel because they have the same slope, different y-intercepts. Now let's examine the new line. So E prime, F prime. Let's see what happened to that equation. This time we're going down 1, 2, 3 over 3. So this time our slope is negative. Our y-intercept is still at 6. And then let's check out G prime, H prime. So we are going down 1, 2, 3, 4 over 1, 2, 3, 4. So still a negative 1 as our slope. And our y-intercept is still negative 2. So notice that these also have the same y-intercept, or I'm sorry, same slope, different y-intercepts. So we can still see that they are parallel. Okay, and then obviously the distances are still the same. So no matter what transformation you do, okay, the parallel lines will still remain parallel after the transformation is complete. All right, I'd like you to try the homework set for this lesson, and we will go over that in class tomorrow.